Okay, we're going to talk about functions that are inverses and sometimes how domains are restricted. So let's go ahead and find the inverse of the x squared function. Remember what I said in the last video, swap the x and the y, so you'll rewrite it as x is equal to y squared. Now to get the y by itself, you take the square root of both sides. So when we take the square root, notice the square root cancels the squared, and now you have y is equal to the square root of x. But here's the dilemma. When you take the square root of x, you can't take the square root of a number smaller than 0. So then you have to restrict the domain where x is greater than or equal to 0 only. So x squared does have an inverse, but the only inverse that it has is for these domain values. All right, so I'm going to put this back up. Let's look at, go ahead and erase that, the inverse of the square root. So you swap the x's and y's. Then in this case, we would square both sides. When we square both sides, we can cancel the square root and the x squared. And now we have x squared is equal to y. So I'm going to show you graphically what that looks like. So notice here we have y is equal to x squared, and this graph right here is y is equal to the square root of x. And remember what we said about the inverse of the x squared? The only domain that we can look at is this domain. And then look at graphically, if you look at that red dashed diagonal line at a 45-degree angle, it creates, if you were to fold this side over onto that side, they would sit right on top of each other. So not only graphically you can see that they're inverses, but algebraically, as long as you restrict the domain, you can see how x squared and the square root of x are inverses of each other. All right, that's it for this one.